excitement! Injabule mtaneni. Yo, I've been dreaming to come to this section, but we had to start from somewhere, right? Like, let's begin somewhere. So, this is my favorite section of mathematics, like the high school mathematics. This is my favorite section. Okay. So they're asking us. Calculus is my first love. Like, okay, I can't even contain my happiness. Okay. Let's dive in deep and solve these problems because, yeah. Okay, so.
We see 100%. We work 100%. We try 100%. We are going to varsity. Destination is varsity. Destination is varsity. Varsity. Destination varsity. Destination is varsity. We see 100%. We work 100%. We try 100%.
Subscribe to our channel, like our videos, turn on the notification button because the destination is varsity. Yes. Excitement! Injabule mtaneni. Yo, I've been dreaming to come to this section, but we had to start from somewhere, right? Like, let's begin somewhere. So, this is my favorite section of mathematics, like the high school mathematics. This is my favorite section. Okay. So they're asking us. Calculus is my first love. Like, okay, I can't even contain my happiness. Okay. Let's dive in deep and solve these problems because, yeah. Okay, so. They ask, this is calculus, né? You normally do derivatives here. It's either derived from first principles or you use derivative rules. Simple as that. You remember when we're dealing with what do you call the functions, né? We talked about the parabola having a shape like this. And we said there's a turning point somewhere here. This is our turning point in a parabola, né? It is more like a turning point. Why is my P? My handwriting is cute. Okay, cool. So if your function, your quadratic function or parabola normally looks like this. F at x equals what? Ax squared plus bx plus c, ne? So to determine the derivative of this, you literally say f prime of x is equal to, then you take this exponent, like this 2 over here, you multiply it by here. You multiply by 2, you multiply a coefficient of x by that power, by that exponent. So literally be what? 2a, then you retain your x and you minus 1 from that number that was here in the exponent. So the number that was here, it's 2 in this case. You minus a what? A 1, right? Then it's going to be to the power of 1. But you normally don't write 1. You can if you want to, but I mean, a 1 doesn't do really anything because if you have an x like this, you know there's a 1 here, there's a 1 here, there's a 1 here. I mean, it's surrounded by 1s, ne? So you don't normally write it like that. You just leave it as it is. So yeah, just so that we look like mathematicians, I suggest you also do the same. We just eliminate this one, right? Okay, but we know there is one there. You do the same thing with bx, ne? So you literally say, let me use maybe a red so that it's clear. You literally say plus, but you also multiply by 1. You don't write 1 plus b, then you say x. In that 1, there was a 1 here, right? You minus a 1, right? So that means now you'll have a what? A 0, ne? You'll have a what? A 0, ne? Okay, you'll have a 0 over here, right? So that means it's to the power of 0 now, right? To the power of 0, ne? And then you have your plus c. I mean, your c doesn't really have any x, what do you call? Yeah, any x next to it. So it's more like you're saying your c is equivalent to, this is equal to c times x to the power of 0, because anything to the power of 0 is 1, eh? So it's more like c times 1. It's equal to what? C times 1, c times 1, c times 1, c times 1. That's your c, right? Let's write it as that so we can be able to use these rules. Let's say it was x to the power of 0 here. I know it's 1. So that means we're going to multiply by this 0 over here, right? And minus a 1 again from this 0. So that means you'll have a 0 times c. That's more like a 0 times c, right? Times x. 0 minus 1 is minus 1, right? Therefore, your f prime of x is going to be 2ax. Anything to the power of 0 is what? Is 1 plus b. Anything times 0 is 0. It doesn't matter what you have. If you're multiplying anything times 0, that means it's a plus 0. So, therefore, your final answer is going to be, therefore, f prime of x will literally be what? 2ax plus b. So you can just head from here straight to this section. I was just doing for those maybe who don't know how to do derivatives, but generally it's as simple as that. Why am I doing this? I'm recapping so that when we're doing derivatives, no one is left behind. We need to move. This is my favorite section. I'm getting some goosebumps. Like, okay. I love this section of mathematics. Trust me. Like, this used to be my fave. When I'm doing derivatives, even in an exam, I'd literally feel like crying, man, when I'm when I'm seeing a derivatives question. Like, this is my favorite, for real. You can even deny me food and just give me derivatives. I'll literally solve derivatives and then not eat. Okay. So it's 8.1. They're saying derive from first principles. What are first principles saying? It doesn't change. You need to master it once, then you're a master of this thing. Maybe that's why I love it, because it's not that complicated. It's easy. So f at x, it says from first principle, f prime of x is equal to f at x plus h minus f at x all over h. That's your generic formula for first principles. What does that mean? I mean, it's simple, like very. So it's more like, and then you say your limit as h approaches 0, ne? You know what I'm saying? I won't go to its derivation, because I mean, you're still in high school, so deriving formula is not really part of your scope. Okay, let's just do. You can go an extra mile, maybe email info destination varsity and ask how do you develop proofs, but that's just not that useful at this point. Okay, cool. So if you were to determine a derivative of this with not from first principle, the answer is gonna be what? 4x. It was just gonna be 4x, right? So let's see if using first principles will give us the same answer. I use the same logic that we say 2 times 2, 4, anything like a derivative of a constant is 0. So yep. Okay, let me erase this guy over here. Okay, let's determine this. Let's first start by determining f at x plus h, ne? F at x plus h is equal to 2x plus h squared plus 4, right? That's equal to 2x plus h, x plus h plus 4, right? Okay. Agree. So that means it's 2x squared. I know this should be 2xh plus h squared. I mean, you can always double check that by multiplying this with this, and this with that. I mean, it's just simple as dirt. Then you say plus 4. Then you will be having, this is f at x plus h, right? F at x plus h, ne? F at x plus h. F at x plus h. So you'll now be having 2x squared plus 4xh plus 2h squared plus 4, right? You feel me? Okay, what is f at x? What is f at x now? You know that your f at x is equal to 2x squared plus 4. Okay. What is f at x plus h minus f at x? This is equivalent to 2x squared plus 4xh plus h squared minus, that's your f at x, right? Minus 2x squared plus 4, right? Right? Then you close this brackets. Okay? Okay. Why am I determining these things? Why am I determining these things? I'm trying to, simplify this guy over here. When you look at it, it says you need to have f at x plus h minus f at x. So when I calculate these things, so when I calculate the derivative, I just plug in whatever answers I'm getting. You know what I'm saying? Okay. That means now you have 2x squared plus 4xh plus h squared minus 2x squared minus... Oh, was there plus 4 somewhere here? I think I missed the plus 4. Remember, f at x plus h had a plus 4 also here, right? This plus 4. Okay, I think I missed it. So it should be here, ne? There should be a plus 4. Okay, let me maybe create some space for me. It should be a plus 4 minus, ne? You get what I'm saying? So even here, before we add this, let's have a plus 4 minus, ne? A plus 4 minus, right? So it'll be 2. Oh my gosh, my god. Now we expanding the brackets, right? So we can't be writing the same thing over and over. So this multiplies there and it changes sign, ne? Okay, so it'll be minus 2x squared minus 4, right? What are you noticing here? This guy and this guy will cancel, right? This guy and this guy will cancel, right? Okay, now you're left with what? What are you left with now? What are you left with now? You'll be left with 4xh plus what? H squared. This is the only thing that you're left with now. This is because everything else cancelled, right? Okay. So now this is equivalent to what? This is equivalent to what? This is equivalent to this is your f at x plus h minus f at x, ne? So now what is your f at x plus h divided by h? What is your f at x plus h minus f at x divided by h? This is equivalent to 4xh plus h squared all over h, right? Which can be denoted as, it's up to you. You can take a common factor here in the numerator, which is your h, right? Take it out like this. You'll literally be having your h, and then you have your x, your 4x plus your h, right? All over h. Are you noticing that this guy will cancel with this one, eh? This will cancel with this one, right? Then now you'll be left with what? With 4x plus h. And this was what? F at x plus h minus f at x, right? All over h. So now, what is the limit? What is the limit? Limit as h approaches 0 of f at x plus h minus f at x all over h. This is equivalent to 4x plus, you know this thing over here is the same as this, right? So we can just replace that with dirt, ne? Okay, so that means now you have limit. Okay, let's use our standard color, which is black. Limit as h approaches 0 of 4x plus h. I mean, this is linear. You can literally sub in here now. You can literally say, so you can plug in your h. This is equivalent to what? This is equivalent to 4x plus, that's your 0, right? That's 4x, no, sorry. That's 4x, that's 4x, that's 4x. That's 4x, not 4h. Therefore, it's equal to 4x. You know that this is equivalent to f prime of x, ne? This is equivalent to f prime of x. It doesn't matter how you arrange your work, but I was just taking you through the steps. What you need to know from first principle is that you don't just plug in your value of h equals 0, right? You don't just plug it in. You need to simplify it and ensure that there is no h that is in the denominator, right? That's why we went all the way and took it out, took our h out of the as a common factor over here, and then we made sure that we cancel this h before we can plug in what the limits, né? Well, can we check if our answer is correct? Can we check? You remember when we said the derivative of this is 4x, right? From our quickest forms. What did you get? What did you get? Did you also get 4x? Did we also get 4x? Yes, we got 4x. Yes. How many marks do we have thus far? How many marks do we have thus far? 4 marks. Okay, okay. But this is so simple. It doesn't change. If you master it now, you've mastered it for your whole entire academic endeavor as a high school student. This is so easy. These are easy marks that are up for grabs. Even if they give you an equation like this, I'm just making a random equation. Maybe f at x being equal to square root of x squared plus 2x minus 4. And then they ask you to determine the derivative from first principle, ne? You literally use the same thing. You plug in, you start by plugging in what? You'll start by plugging in f at x plus h. Wherever there is x, you plug f at x plus h, x plus h. You expand it as soon as much as you possibly can, right? And then you minus f at x from that, which will be literally this one. Then you try and kill the h that is in the denominator. Remember there was an h in the f at x plus h in the original equation. Ne? You try and take out h as a common factor here so that you cancel this h. Then you plug in your limits as h approaches 0. It's simple. It doesn't change. These are easy marks. If you don't get this one right, blame yourself. Like, just blame yourself. You're losing easy marks. You are losing easy marks. You're missing out on the fun. Okay, how do you then determine derivatives of this? How do you derive this? How do you derive this? How do you derive this? Simple. Don't complicate things. I mean, this is 8.2.1, so this literally means f prime of x. You multiply with, okay, let's not start by determining f prime of x, so we simplify it. Let's say f at x, let's write it in standard form, because you want your x to have an exponent every time. You know 5, this is the same as to the power of half, ne? Like square root is equivalent, like square root of x is equivalent to x to the power of half, ne? And cube root of x is equivalent to x 1 over 3. If there is anything like fourth root, whatever root, power of that. But if there is a square root only, there is literally, assume there is a 2 here. Just assume that, then, yeah. You get my point. You do get my point. You are very smart. You're getting my point. Congratulations. Okay, cool. Then f prime of x would literally be you multiplying this with this, which is gonna be 6 minus 6. Then minusing 1x. Multiply this with this, gonna be 5 over 2 minus 1. It's what? It's over half, right? I mean, you can leave it like this if you want to, but as a mathematician, this is not nice, ne? You need to make sure that it's low-key in the standard form. Minus 6x plus 5 over 2. This is more like, I like to think it's like this, ne? X to the power of 1 over 2, right? Because this is more like a reciprocal of that. But you can always write it like this. F prime of x equals minus 6x plus 5 over 2 root x. Because this is like root x. Ne? I mean, it's entirely up to you. But make sure that you simplify it as much as you possibly can. Because these people can literally place marks in random places. So you don't want to lose easy marks because you're lazy, right? Okay, this is easy using the Varsity method, but we'll start with the Varsity method, then go to the high school method. The Varsity method is the chain rule, ne? Chain rule. How do you use chain rule here? So chain rule says, if you have f at x being equal to g of k of x, therefore the derivative of f at x is equal to g prime of k of x multiplied by k prime of x. Okay. Yo, this is so nice. So it says you derive what's on the outside first, and then you multiply by the derivative of what's in the, like, Okay, cool. So how do we put that into practice? So you guys will be able to follow my logic. Okay, it says, you have p of x, right, being equal to 1 over x cubed plus 4x all to the power of 2, right? So according to the chain rule, I would be literally saying I derive outside. So it would be literally 2 times what? 1 over x cubed plus 4x multiplied by the derivative of what's inside. Then it will be literally, because 1 over 3x cubed is the same as this. So I'll multiply by minus 3. So it'll be minus 3. Then minus 1, x to the power of minus 4, right? Plus 4. Because the derivative of this is 4. So according to the chain rule, this is the answer, right? You can always expand maybe by multiplying this with this, this with that, this with that, this. But then that's like tedious. I can just leave it like this. This is the answer according to the chain rule. Okay. According to the high school method now. According to the high school method. Okay. According to the high school method now, which says things should be in a standard format first. So you literally have 1 over, you can write, this is cubed, right? Plus 4x. You can write this like this, no? X cubed plus 4x. Then you have p of x being equal to, then you take this, multiply here, and this multiply here. Then it will be literally 1 over x to the power of 6 plus this times this, it's 4 over x squared. This times this, it's plus 4 over x squared. This times this plus 16x squared, right? Okay, therefore p of x is equal to 1 over, okay, let me write it in standard form. It should be x minus 6, ne? Plus, this is more like, this is equivalent to what? To 8 over x squared, right? But in standard form, it will be literally 8x like this, ne? In standard derivative form. I call it standard form because that's where I'm able to do my derivatives nicely. Okay, cool. And then now you start determining the derivative. You literally say p prime of x is equal to minus 6x to the power of minus 7. Then minus 16x to the power of minus 3 plus 32x. Ne? So I think this is the answer. The logic is still the same. It holds. If I did a calculation error, yeah, correct it. Don't take my answer as it is. Take my logic as it is. So it's all about teaching you how to think. Yeah, but the Varsity method is easy than we're done with this one. Off to the next one. Next question, please. Okay, from first principles. Okay. From first principles. I mean, do it yourself. This is so easy. This is so easy. So I know the answer that you should be getting should be 4x minus 1, right? So determine just to give you some hint, from first principle, f prime of x. Okay, my handwriting is so nice, ne? F prime of x is equal to f at x plus, limit as h approaches 0, right? Minus f at x all over h. And then f at x plus h here, f at x plus h is going to be 2 into what? X plus h squared minus x plus h. And then you expand this, it will be what? 2 into what? X squared plus what? Plus 2xh plus h squared minus x minus h, right? That's going to be what? 2x squared plus 4xh plus 2 plus 2h squared, right? Plus 2h squared minus x minus h, right? Okay, cool. So what's this minus? What is fx plus h minus f at x? It's gonna be what? 2x squared plus 4xh plus 2h squared minus x minus h. Then you minus the original function, which is literally this one, right? You minus this because that's your f at x. Ne? This is so simple. I'm just doing it so that people don't complain and be like, no, why didn't you do it? But it's so simple. Simple things, they tend to be boring. Like, honestly, when something is too simple, it starts getting boring. Like, it's just bores me. Minus 2x squared. Okay, minus x, ne? Minus x, right? It's plus x. Some things should cancel at this point. Like, it's so routine, this will cancel with that. This will cancel with that. Then you're gonna be left with what? You're gonna be left with, let me delete this, sorry. Then you're gonna be left with, 4xh minus plus 2h squared, right? Plus 2h squared minus h, ne? Then you take your h as the subject of this thingy. Will be 4x plus 2h minus 1, right? Okay. And then, okay, cool. Let's go back to the original thing. Okay. Okay, then now, because this is equivalent to what? F at x plus h minus f at x, right? But what is f at x plus h minus f at x all over h? So it's more like you're saying this, or the same thing. For x plus 2h minus 1 all over h, then your h's cancel. It's so routine and it's boring when it's this routine. If you get this wrong, you deserve a beating, trust me. For x plus 2h minus 1, then you take a limit because you've eliminated the h that was in the denominator, right? Then now you take a limit. You take a what? You take a limit as h approaches 0. So you literally say, therefore, f prime of x is given to limit as h approaches 0 of f at x plus h minus f at x all over h. That's more like limit as h approaches 0 of f of 4x plus 2h minus 1. Then it's gonna be 4x plus 2h. H is 0 because it's approaching 0 minus 1. Therefore, it's gonna be 4x minus 1. Let's confirm if this answer is correct. That's your f prime of x, ne? Let's confirm if this answer is correct. Yes, it's the same as this one. So we are correct. We have 6 marks. Like 6 marks. Do you see? Easy 6 marks. Easy 6 marks. Just easy. As easy as that, you've backed yourself 6 marks. Imagine. 6 marks. Literally, you have 50% of this question because it's 6 over 12, right? Okay, then they're saying determine a derivative if this is this. Is this in standard form? No. So that means I'll literally say, let me expand it then. Let me say x plus 1. I'm just expanding this guy that is inside, ne? I'm expanding what inside. 3x minus 7. That's for this times this times this times this times this. It's going to be 3x squared minus 7x plus 3 minus 7 plus 3x minus 7. And then you literally be having 3x squared. Hey, my tree looks cute, eh? 3x squared minus 4x. It's minus 7 again, eh? Therefore, dx of this is equal to this times this 6x and then minus 4. Done. You know what I'm saying? It's so simple. If you fail these things, you deserve a beating. Trust me. You just deserve a beating. Or you deserve to, I don't know, but you deserve a beating. That's the, yeah, that's what I can think of right now. Why are they saying dx here and why are they saying dy over dx? It's because here they only have x, ne? Here there is y. So if this equation was like y equals x plus 1, 3x minus 7, they were gonna say determine dy over dx, ne? But now it's only has an x, so determine. But it's the same thing. You employ the same logic. It doesn't mean there's a different like approach that you need to take. Okay, cool. Let's make this in standard form again. You know our, hey, go back to where you're coming from. You know our standard form is like this. It should be x 3 over 2, right? Minus 5x minus 1 plus half pi, ne? Don't be conflicted by this pi. Pi is a number, 3.14 something. So this is more like a constant. You know the derivative of this thing will go to 0, right? So don't be conflicted by that. This times this, it's literally going to be what? 3 over 2x. And then I think it's half here. Because 3 over 2 is 1.5. 1.5 minus 1, that's 0.5. 0.5 is half. Minus, then it's going to be 5x minus 2. That's 0. In standard format, how would this look like in standard format? In standard format, delete you, please. Go away. Get away. Go away. So in standard format, again, it's going to be 3 over 2 root x. Then you can also have plus 5 over x squared, because this guy, I mean, you don't need exponent. Like your answer should be nice, it should look cute, and that's what this is your dy over dx, ne? Yeah, this is what your dy over dx, ne? And this is okay. Delete you text. What do you mean I should add text? Hobby. Why should I add text? This is what? This is your y, ne? So do you know this, so that people will be able to see, oh, you started, is this dy over dx? Let me confirm. Yeah, this is dy over dx, ne? Yeah, and this is us putting it in standard format. And this is your y. So denote, because now if you don't denote which one is one, which one is what, go back to your original form. Which one is y, people won't be able to see what you did. So this was originally rearranging it in a standard format, and then this is us now starting to take derivatives, rearranging derivative to a standard format. That's it, ne? That I'm saying. So yeah, you literally have 12 marks in the back. Aren't you happy that you literally backed 12 marks just like that? I mean, 12 marks is something, man. Like, easy as that. I mean, guys, we can do these questions until it stays like this. It doesn't change. If you start somewhere, email info@destinationvarsity.com. It's as simple as this. It will never change. If it changes, apply your logic again. Convert to standard format. Make sure everything, that there is no x that is in a denominator when you're deriving. When you're deriving from first principle, make sure you eliminate your h in the denominator. So there is nothing that should be in the denominator that's more like a variable or something. And then you use the same logic. So try by all means to simplify it, convert to standard format. Doing more question papers will be us wasting time. You can do more question papers because you're writing exams. So I gave you this thinking thingy. Employ it to your academic endeavors. All the best. See you on the other side. Lots of love. The other side is varsity, hey? Don't get me wrong. Bye.